Hello everyone. Let us take our discussion to the concept of hashing now. So let us see what is hashing and how we can write a simple hashing algorithm and how we can get a home address and how we can store the things into uh, that particular address. So let us see the introduction part. What exactly the definition of hashing? If you consider this diagram, so you can see there is a key called lowell, and you can see h of k, we call it as hash address. So the function to calculate hash address, and this h of k is going to give you a particular address to which you are going to copy the key lowell, right? So these are the memory, your memory, computer memory, and these are the address you have. What exactly hashing is doing? So you will be having a particular key, and that using that key you are going to find out a home address for that particular key using some function h of k, and that home address will be uh, considered, and that key will be copied over to that home address. Key along with the record that will be copied over to the home address. So for example, let us consider these sets. You have three different keys over here. How can I write h of k now? What I am doing here is I'll consider the first two characters BA. This is just an example. You can go for so many hashing algorithms will be there, so you can go for any hashing algorithm whichever comfortable for you. So now for example, let us see how we are going to write h of k. So we have three different keys over here. I want to find out the address for that keys, right? So how we can find out the address? I can find out the address using some algorithm or some function, that is nothing but h of k. So in order to find out the address of first key, so I will take the first two characters B and A. So capital letter B is having ASCII value of 66 and A is having 65. So what we are going to do is I am going to multiply 66 and 65, and I got a number, and its last three digits I am going to consider as the home address. So my algorithm is select the key, select the first two characters of the key, take its ASCII value and multiply both values. You will get a result. Take that result and its last three digits will be considered as the home address of that particular key. Now you are going to save ball in 290th position. You are going to save lowell in 004 position. Like that you are going to save the key, that is the home address. Now what do you mean by collision? So suppose in the previous slide we had seen the home address, but what will happen if I have lowell as one key and LO as one more key? So what will happen? Lowell and LO, both first two characters if I consider, what will happen? Both are having same home address. Now LO and LO, if you multiply you will get the same home address, right? So if you get the same home address, can you store the item over the same address? No, there occurs a overlap, right? So that case we are calling it as collision. So how we can avoid this collision? There are four different ways. One is you need to write a perfect hashing algorithm your hashing algorithm should be very perfect, such that there is no collision occurs, right? So nobody can write such a perfect hashing algorithm. There might be one or the other mistakes in the sense you will get one or the other way, you will get collision. So instead of that, we have the next particular option, we call it as spread out the records. So your hashing algorithm should be such a way that it is going to spread out your records more randomly. That means your algorithm should support a particular way that should spread out the records more randomly, and there is a less collision in your algorithm. And the next method is use extra memory. If suppose you have extra memory, you can spread the records more easily, right? If you have extra space, you can spread it easily. If you have congested space, you cannot spread it easily. So that is why use the extra memory to spread the record uh, nicely, right? Next method is put more than one record at a single address. You have a concept called as bucket, buffer, all those things. So try to use that concepts into this hashing algorithm, and then try to put more than one record at a single address, so that less number of collision will occur. Now let us see a simple hashing algorithm. Now I'm taking a small hashing algorithm which has 3 different steps. So in this algorithm we have the first step as represent a key in a numerical form. If it is already a number, then the first step can be avoided. Next step is fold and add. So you are going to fold the characters and you are going to add it together to get some particular address. Then divide by prime number and use the remainder as the address. So the last step is you are going to find out one single address using division by prime number. Let us see an example for this. I have to consider its ASCII values also. So 32 is the ASCII value for blanks, so I have considered 6 32s. Okay, so that is representation of key in numerical form. That is the first step. Next you have second step as fold and add. That means you are going to fold the numbers and you are going to add it. Now say the first two characters are having 76 and 79, so I am going to write it together 7679. That is one fold is over. Next 8769, that 8769 is the second fold. 7676 is the third fold. Next comes 3232, once again 3232 and 3232. Now you have folded it, right? Now how we can add it? So while adding, what I am going to do, I will take the first fold 7679 plus second fold 8769 and so on. I am going to add it. After adding, I got the result as 33820. But suppose we use 15-bit integer expression, then the maximum limit is 32767. That you need to keep it in mind. If you use 15-bit integer expression, 32767 is the maximum limit. So now if you consider your answer, this is greater than 32767, so I can conclude that there is an overflow. So I don't want any overflow over here. So what I am going to do is I will select the largest addend. So largest addend you can consider is ZZ. Largest character will be Z. So ZZ will be the largest addend. I can take it as 9090, right? ASCII character is 9090. So together after folding I can get it as 9090. Now what I am going to do is I am going to find out the largest allowable result. So how can I get it? We have the limit as 32767 and I'm going to subtract 9090 from that. So 19937 I'm going to get. Now I'm going to find out the mod I'm going to use a mod operation and find out the reminders now. So what I'm going to do now is I'll select the first two characters ASCII value, which is folded 7679 plus 8769, right? And for that result I'm going to mod it with 19937 so that I can get the result which is less than 32767, right? So in the same way, now I got 16448. For that I'm going to add the next particular folded uh, folded character 7676, and once again find out the mod. You got 4187. So take this 4187, add the next content, that is 3232, you got 7419, and so on, and finally you are going to get the result as 13883. So after fold and add, now your result is 13883. After second step, your fold and add result is 13883. Now what is the third step? In the third step, you are going to divide by zero size of the address space, right? So how can I do that? I have a formula A is equal to S mod n, where A is the home address, actual address what you are going to find out. S is the sum product in step 2, whatever answer you got in step 2, that is S, and n is the number of address in the file. Say you have 100 address in the file. So this is the example. Now how can I find out the home address? So I can find out the home address of Lowell as 13883, which we got in step 2, mod 100. So you will get it as 83. So one thing we need to consider is, if you mod any number using prime number, then it will make that will make distribution more random. So a prime number is usually used for the divisor because primes tends to distribute reminders much more uniformly than do no primes, right? So here I had taken 100 is the address. So 100 is the address, so I had taken 100, but instead of 100, if I take it as 101, then it will be much better, because it is 101 is a prime number. So if you use a prime number, collision will be much more reduced. So always in the step 3, we refer as address space, but instead of that, nearby prime if you consider, that will be better option. So if you have suppose 75 records, so n is 75, instead of 75 take the nearby prime number, that is 101. So if I have 75 records, then 101 I need to use. So 13883 mod 101, so I will get some particular answer. Say it is 74.3%. So this is how we are going to do the step 3. This is a simple algorithm. We are going to study so many other hashing algorithm later onwards. Hi all. Now let us start with the concept of making deletions. So whenever you are going for a record which is stored in an actual address using the home address, it might be using a progressive overflow method, and while searching a record from the memory, whenever you delete some particular record, what will happen is that deleted space will get empty, right? And when you do a progressive overflow method, when you get an open address, that is when you get an empty slot, your search will wind up, right? Your search will wind up whenever you will get an open space. So what exactly we can do to overcome this problem? We will consider an example. Say these are the different records you have, and these are the home address, and I have stored it using the progressive overflow method, and this will be our actual addresses whatever we got after inserting it into the home address. So you are going to store Adams over 5, Jones in 6, then Morris home address was 6, already John's has been saved over there, so we are going to save it in 7, so actual address has become 7. Then Smith actual address is 5, so we will go for progressive overflow method and we are storing it in 8, right? So when I want to delete some particular record from this, say I want to delete Morris, okay, so when I delete Morris, what will happen? This Morris place gets empty, right? Now I'll go for progressive overflow method once again, and I'll search a particular record now. So when I search a particular record, say I want to search John's, right? So what will happen? It will go to the first address 5, Adams was there, it is no key doesn't match. Now it will go to 6, John's we got, key matched, and it will come out of the program and display key is found. Say you want to search something, like you want to search Smith now. So how can you search that? Once again, progressive overflow method, it will start from Adams, there is key doesn't match, it will go to next slot, there is something, it will match, Jones and Smith doesn't match, so it will go to the next position is empty, right? When you get an empty position, the progressive overflow method will wind up saying there is no further records, so it is empty now, so Smith is not found. But actually Smith is there, right? Actually there is a record called Smith, but now your program is wrong, isn't it? So how can you overcome with this? One method is, whenever you are going to delete the record in between, then you can shift the place of the next particular record. You can shift if you have 10 more records after this, so you have to shift everything to the previous positions, right? So that will become complicated process, because time is wasted, as well as it will have so many steps to do all these. You have to have a separate algorithm for this, and it will take time. So instead of that, what we are going to do is, we have a concept called as tombstones. So tombstone is nothing but, whenever you are going to delete some particular record, in that position we are not going to make it as a empty slot. Instead we are going to put some particular symbol over to that position, so that we can understand that position, the elements data got deleted, and the method progressive overflow, while doing the progressive overflow method, what will happen? In that position there is some particular data, right? When you insert some symbol into that position, that means in that position something is there. So progressive overflow method will not wind up to that position. So both our confusions will be getting cleared. So let us take an example now. As we have deleted Morris from this position, this is empty now. So what I am going to do is, I will put these tombstones over to that position. So I have taken hash symbol and I have put some hash symbols over to 7th position. Now when you search Smith, what will happen? It will start searching from Adams, no match, Jones, no match. It will come to this position. There is some data, hash. It will be considered it as a character. So Smith matched with these characters, no match. It will go to the next position and there is a match. So our problem got solved now. So simply put some particular symbols, we call it as tombstones, into the position where you are deleting the data, and progressive overflow method will be repeating, continuing its process. So this is how you can handle the deletions. Hello everyone. Now let us see something about hashing functions, different hashing functions and record distribution. First let us see what is record distribution in hashing. Not see any collision over here, right? There is no collision over here. So we can call it as best case. So what do you mean by worst case? Worst case means all the records are hashed to only one single address. That is the worst case. So completely collision, right? So if you consider here all the records are collided to 5, right? So this is called as worst case. So what do you mean by average or acceptable case? There might be one or two collision. If you see address 3, B and G is collided to address 3, right? If you see address 10, D and F are assigned to address 10. So there will be slight collisions, but maximum we try to avoid the collisions and we try to make our hashing function perfect, right? So this is the average case. Usually all our algorithm belongs to this particular acceptable cases, because worst case if you do, your algorithm is a failure, right? So your function is a failure. You have to try for best so that you can get at least average performance, right? So these are the three different distribution methods. Next let us see what are the different hashing functions you have. So I have 5 different hashing functions. You might have more than that also. So simple hashing function here. So the first one you can see, examine key for a pattern. That means you will be having a particular pattern and you are going to change slightly in that pattern so that you are going to get the address. So for example, if you see a set of employee identification numbers might be ordered according to when the employees entered an organization. That means you will be having your USN itself. So how you are going to get the USN? According to your alphabetical order of your class, right? Your names. So you are going to get USN 1, 2, 3. How you are going to change the USN? You are going to change the USN only in the numbers as well as year. If suppose you are entered the college in 2017, then your USN will be 17. Then that 4CB will be as it is, right? You are not going to change it. That pattern is same for all your juniors as well as seniors. Only the years and numbers will change, vary. So you are going to have here in this example what they are telling, employee ID, the initial part will be same as it is, and only the numbers will vary accordingly when they enter into the organization. So this is, you are going to set a pattern and you are going to modify slightly to get the particular address, right? So this is the first hashing method. Next you have fold and add method. We have already seen in the first example of hashing, where you are going to fold the numbers, add those numbers, and you are going to get the address using ASCII numbers, folding it, adding it, and then divide by a prime number. So that is the fold and add method. That also you need to mention while writing in exam. Then the third one is divide the key by a number. So usually division we are going to do, that is a simple hashing algorithm, where you will be having a key and you are going to divide it by a number. So usually dividing the number by a prime number, so that you will get less collisions. So fourth method is mid square method, where you will be having a key, you are going to square that key and consider the middle part of that key. That will be your address, hash address. So if you consider this example now, if the key is 453, its square is this number 205 209, right? So what I'm going to do is I'll consider the middle part 52. So extracting the middle two digit yields a number between 0 and 99. In this case it is 52. So that is the mid square method. You can also go for, if your address is larger, you can also go for 3 or 4 digit number. It depends on your address, how many memory, how much memory you have, depends on that. Next, fifth hashing method is radix transformation, where you will be having a key and you are going to convert that key to some other number base. That means suppose you want to generate address between 0 to 99, you have 100 addresses, you have 100 memory space. Then if the key is a decimal number, say 453, I am going to convert it to for base 11 equivalent. So base 11 equivalent is 382. 453 base 11 equivalent is 382. So what I am going to do after that, I am going to do 382 mod any number. So instead of 99, I can also choose 101, which is a prime, which will give me a best answer, best solution. So better we can use 101 over here. So what will happen, 382 mod, here in this case 382 mod 99, I took a random number 99. How I have taken is 0 to 99 is my address. So biggest address I had taken 99, and that I have modded. So you can go for the nearest prime number 101 also. So got the answer. So 85 is the hash address. This is how radix transformation occurs. So these are the different simple hashing methods you have.